Okay, number 12. Finally, a sample of gallium bromide, GaBrX, weighing 0.165 grams, was dissolved in water and treated with silver nitrate, AgNO3, resulting in the precipitation of 0.299 grams of silver bromide. Silver bromide. Use this data to calculate the mass percent composition of GaBrX and its empirical formula. So first, what I'm going to notice is that we have our grams of gallium bromide, and I'm also going to notice that we have a precipitate of grams silver bromide. And what I'm going to do is I'm going to say that I'm going to use my grams of silver bromide, and we want to get that to moles silver. I almost wrote silver bromide. Change that to moles bromide. I'm going to put moles bromide to grams bromide. And the reason we want to get grams bromide is because we want the percent of bromide in this. We're looking for this X here. So that we're going from grams of silver bromide all the way down to grams of bromide. And so I'm just going to write down the molar mass of silver bromide. So I'm going to put 187.77 grams Ag bromide per 1 mole. And then I'm also going to say that the molar mass of bromide, which is 79.904 grams bromide, is in 1 mole of bromide. So we have our molar masses. Now we're going to start with this value right here, which is given right here. Okay. From there, we're going to use our molar mass that we found, which is 187.77 grams of Ag bromide, this is grams. I forgot to put the grams. Into 1 mole Ag bromide. I put bro. And then from 1 mole of Ag bromide, we're going to get 1 mole bromide. I keep putting bro. And this is going to equal 0.00159 moles bromide. Now I know, why are we finding moles of bromide instead of, grams of bromide? And really all we're doing is we found the moles. And so then we can, find the grams, which is that whole number. I'm just going to multiply it. 79.904 over 1 mole. And that's going to cancel out. I don't know why I did it that way. But that's going to give you an answer of 0.1272 grams of bromide. From there, you can calculate the percent of your bromine and your percent of your gallium. How you're going to find the gallium is you would take the grams, I'm going to put this in red, the grams that are here, this total, and you're going to subtract it by the grams of bromine. So I'm going to put it right here, 0.165 grams of, and this is GABRX, and we'd get 0.0378 grams of gallium. And from there, we can find our percents. So we know we have gonna write it down. Percent R equals 0.1272 grams over the total 0.165 grams times 100 equals 77 point, I don't know why I put a point there. Sorry, 77.1%. And our percent gallium grams equals 22%. Oh, sorry, 22.9%. So we have our mass percents of the composition, but we still need to figure out the mole per gram ratio. And how we're going to do that is we're going to take the grams that we found of gallium, and we're going to take the molar mass of gallium, which is, so I'm going to put 0.0378 grams to 69.723 grams to 1 mole. GA. This is grams GA, gram, they cancel out, boom, boom. And that equals 5.42 times 10 to the negative 4 moles of GA. Now, how are we going to find the amount of, like, bromine to gallium? Like, what's that ratio? How we're going to figure that out is we're going to take the moles of gallium, and we're going to take the moles of bromine that we found earlier, which our moles of bromine was 0.001592 mole BR. I don't know why this wasn't long enough. And then 5.42 times 10 to the negative 4 mole gallium. And that should equal approximately 2.94, which means that ratio is supposed to be 3. Why are we doing moles of bromine over moles of gallium? I know for some of the other problems that I have done before, so like this one, for instance, I talked a lot about our molar ratio. And our molar ratio is just, oh, how many of these moles can produce these moles? Or how many of these moles do I need to have a reaction with these moles? Like this. And how, sorry, I'm not going to highlight those ones. I'm lying to you on that part. But basically, if you have like a coefficient, like this is going to relate to the coefficient that's over here. Hypothetically, let's say it's a 3. You'd know it's a 3-to-2 or a 2-to-3 ratio, that kind of stuff. And so when you make that ratio, this is what we're doing. We're making that ratio of how many moles of bromine do I need per mole of gallium. And that ends up being really close to 3. So these are our percents by mass, and our formula is GaBr3.